Hello everyone, and welcome to this latest webinar from IHS Markit. My name is Alan Tatara, Event Manager for the IHS Markit Technology Group webinar team, and I want to thank everyone for joining us. Today's webinar is the future of cable access, converged or distributed. Our panel will explore these two options in access platform architecture along with the overall business case, while also discussing the strategic paths forward for MSOs as they plan for networks of the future. Our webinar is co-presented by IHS Markit along with Casa Systems and their partner Intel. So before we begin, I want to highlight a few features that are available for you on our webinar today. So the console that you're looking at is completely customizable. So this means you can open, close, move, or resize any of the windows that you have open on your screen and arrange the console as you wish. Now you're going to see a number of application widgets at the bottom of your screen. These contain additional features available for you. I do want to mention the resource list widget, and this is where you're going to find additional material about today's topic, including the downloadable slide deck from today's session, as well as other valuable resources. And all these materials can be accessed and downloaded right from your console. And we've also included a Twitter widget. You'll see that at the bottom of your screen. So this means you'll be able to tweet directly from the console. And today we are using the hashtag #FutureOfCable. We will also have a live Q&A session directly after the presentation, so please submit your questions or comments at any time by using that Q&A box that's on the left side of your screen. And if you encounter any technical issues during the webinar, just click on that question mark widget and you will receive the answers that you need. So now let me take this opportunity to introduce our panel. First leading our discussion is John Kendall. John is a principal analyst in the Service Provider Technology segment at IHS Markit. Also joining us is Jeff Leung. Jeff is Senior Director of Product Management at Casa Systems. And rounding out our panel, we have Ed Dilag. Ed is Market Development Manager at Intel. So welcome to all of our speakers today. Glad to have you with us. And now we'll pass the controls over to John so we can get started. So John?
Thank you, Alan. So I'd like to first go over our agenda for this webinar today on the future of cable access. First, we will be doing a little bit of a background with some market trends upon which I'll be speaking. Secondly, we'll go through some problems and challenges of the cable market currently. After that, we will go through new options and solutions. Following that, we'll talk about some deployment applications. Then we'll touch on our sponsor's approach, and then we'll have some conclusions. And then, as Alan did outline, we would like a very interactive audience Q&A, so please do not hesitate to send your questions along as the presentation is going. We will answer them at the end. So to give a little bit of background, I'd like to talk about the cable access timeline to kind of set the stage. So in the first part, we have the CMTS era. It started in 1996. We had the specs released in 96, 97, and that had a steady growth until 2013. That includes DOCSIS 1 and DOCSIS 3.0. In 2012, we moved to the CCAP era. The technical report was released in 2012 with the sales eclipsing CMTS in 2014, which I will illustrate in a slide a little bit later. CCAP era encompasses DOCSIS 3.1, which was released in 2013. And around 2015, we got the technical report. And this is what we've kind of called the distributed era. And this is when cable operators have been exploring and looking at more distributed access architectures. Now we're in a distributed and converged era where operators are looking for an expanded range of physical and virtualized options, whether that be remote PHY, distributed access, etc. And this also includes full duplex DOCSIS 3.1 moving forward. So the case for CCAP, CCAP is an acronym most of you know. It's Converged Cable Access Platform. Globally, this view of the traditional CMTS is essentially finished, as operators have opted for CCAP, and as outlined in the previous slide, CCAP shipments did eclipse those of CMTS, traditional CMTS in 2014. The conversation of the architecture has now shifted from converged to distributed, And what we're seeing in the market is that currently cable operators feel as though the future is uncertain. How to architect their networks moving forward, what are the opportunities, and how to build their networks for a more efficient distribution. But we feel this uncertainty does present a tremendous opportunity for operators to design a more efficient network than what they've currently got. And we do have a consensus. I mean, we're seeing 10 gig EPON playing an important part. Pushing fiber deeper into the network is a key strategy in order to push those higher bandwidth solutions for their customers. And on this slide, I just wanted to give a quick glimpse of the global cable access outlook, and this is from my Broadband Infrastructure Intelligence Service. And here you do see in 2014 where CCAP does pass CMTS, and we do see some micro CMTS, so CMCs as a smaller market segment moving forward, but the vast majority of shipments and value of the market will be in the CCAP space. And now to talk through some problems and challenges, I'd like to go ahead and hand it off to Ed from Intel. Ed?
Great. Thanks, John. Thanks for that great intro. So yeah, I'd like to kind of pick up with the today story, if you will, and the distributed and converged era, I think we called it in the introduction. So, you know, there are a few key trends starting from a consumer perspective. The top of mind is this sort of seemingly endless appetite for bandwidth. And, you know, we're not always sure what consumers are going to do next with all of this bandwidth, but it always does seem to get consumed as soon as it is available, right? So couple that with the changing viewing habits of consumers, moving from sort of the one big screen to many smaller screens together with the big screen, depending upon your age, of course. So my kids never seem to watch their videos on the quote-unquote big screen, but rather prefer to view it on their tablets and even their iPods, as an example. So what this is really driving is a need to shift to IP video delivery to enable delivering content to that multitude of different devices. And of course, the big screen's not going away anytime. For folks like myself who still prefer that as sort of the main screen, you know, I'd like to view my next-gen high-fidelity video in the form of 4K, HDR, etc. All of those things really drive up the demand for bandwidth into my home, right? And of course, operators are anxious to meet that demand. So as John said, that is really, facilitating this trend towards fiber deep, which essentially means more nodes in the neighborhood. And the reason we need more nodes is because in the hybrid fiber coax network, the coax portions on the left of the fiber node on the diagram, that's a shared asset, right? And there are some number of homes that are served per shared coax. If you want to increase the bandwidth per home, one way to do that is to decrease the number of homes served on that shared asset. And so that's where fiber deep comes in. You push more nodes out, less homes per shared coax, and you can therefore, you know, drive more bandwidth per home. So, okay, great. What that means is that you've got more nodes that you now need to terminate into the head end, into the CCAP, which is at the other end of the fiber node and is the fiber end of the fiber node, right? So what that's really driving is a tremendous strain on head ends and hub sites. And these sites, depending upon the size of the site, can be very, very, very challenged in terms of power and available space. So what operators are doing in response to that is looking to distributed architectures, right, in the form of either RPHY or RMAC-PHY. With RPHY, of course, you're just pushing out the PHY portion into the fiber node. With MAC-PHY, you're pushing out both the MAC and the PHY. Doing that does save significant power and space in the head end, essentially shifting all of those sort of analog components, if you will, into the fiber node. secondarily, eventually when everything transitions to IP video, the QAMs as well can go away. And the QAMs, of course, are the sort of the more traditional broadcast video elements, again, sort of the analog type components which do take up significant power and space. So that will certainly help with the power and cooling challenges in the head ends. And what it also does is it enables the virtualization of the CCAP. And by virtualization, I'm talking about transitioning from purpose-built sort of gear towards standard servers and switches. And in my experience, early on in conversations with operators, CCAP was sort of an afterthought, but I think now operators are realizing that transitioning to a virtualized CCAP can actually enable a significant number of new services, which, of course, is important for operators who are looking for kind of the next big thing, if you will. And I think these new services fall into a couple of buckets. At least I've bucketized them that way here. You've got sort of the low latency services that will benefit from being closer to the subscribers. So this would be, for example, augmented reality, virtual reality, gaming, and CDN. And CDN, maybe it's not as latency sensitive, but putting CDN at the edge will certainly alleviate a lot of excess core traffic, right? The second bucket is basically enabling brand new networks using the same infrastructure. And it's a concept called network slicing. So you can literally run both your DOCSIS network together with, let's say, a wireless backhaul network and maybe an IoT network. All of those networks have very different latency and throughput and jitter requirements. And using a technique called network slicing, again, you can basically serve the needs of and meet the requirements of those very different networks, all using the same physical infrastructure, again, once you've virtualized that CCAP element. So with that, back to you, John, and I'll talk a little bit more about wireless a little bit later on.
Thanks, Ed. I can certainly identify with the multiple screen household as my two sons seem to watch their tablets as they watch TV. It's the strangest thing, but that's how it goes in my house. Now we'd like to go ahead and poll the audience. And here's our poll question. So we'd like everybody to select as many of these as apply to their current situation. But question is, which network evolution steps are you planning to take during the next 12 months? And choose all that apply. And I'll read through the choices real quick while I'll give the audience some time to answer. Push fiber deeper with distributed access solutions. Deploy virtualized access solutions. Converge transport for fixed and wireless networks. Converge video and DOCSIS services via CCAP, or none of the above. And now we'll take a look at our results. Wow, so we can see pushing fiber deeper is the leader in the clubhouse, but second is Converge video and DOCSIS services via CCAP. Very interesting, very interesting. Deploy virtualized access solutions is about a third of the audience. Very interesting. None of the above is very interesting to me as well. Well, thank y'all for your answers. And now to talk to some new options and solutions, I'd like to go ahead and hand it off to Jeff from Casa. Jeff?
Hey, thanks, John. It's very interesting results, seeing this distributed architecture and also virtualized solutions actually taking place here. So I'm here to talk about the next generation network, and let me just describe there are actually multiple forms of your future network may take place. Centralized solution, which is like the CMTS or CCAP solution, versus a distributed solution with remote PHY node out there. We talk about physical network, physical chassis versus virtual solution, like what Ed mentioned earlier. HFC plant versus a PON network, which is using like a EPON or GPON. Where should you use HFC? Where do you use PON? And you talk about multiple type of services, right? Symmetrical services or asymmetrical services. And when we talk about video, you have an all-IP network. Are you using IPTV? That will realize some of these multi-screens applications that the kids love to take today, or whether you still want to do an IP and video separately. And also today we have all vertical silos, right? You have your fixed network, you have your mobile network, and Wi-Fi network, all individually managed by different machines, chassis, or management in a platform. These can also be realized by using a virtual solution to do a horizontal multi-surface platform. So there are actually multiple type of networks that the future may take place. So in this, right, so what should operator take, right? There's so many choices in the future, and it really depends on this strategy. Today, everyone is doing the same network because there's not much that you can choose from. But in the future, as I said, there are actually multiple ways that you could do. So what do I mean by that, right? Just give you an example. For example, for an operator A here, right, you could have 48% of the revenue maybe coming from a consumer broadband network, meaning just the internet network. 10% of that operator A may be coming from the IoT applications, right? So maybe they want to flavor about 10% of the revenue with those low latency type of applications, 20% for the enterprise services, and 35% for the pay TV, right? So this is a operator A type of scenario where they may need to do a different types of network. As you can see, it's actually mixed with multiple applications. And there is no one application or one network that can fit everything. And just another example for operator B, that this operator may be favoring like 48% of the revenue, almost half of the revenue by their enterprise services, 10% for the wireless network, 20% for the on-demand video, and 35% of the wholesale transport, right? In this case, they are mainly servicing business. That's the majority of revenue. So if this is enterprise services and this is greenfield, they may favor more like a PON network. So there's a different choice here. And versus an operator C, where 48% is more like a traditional pay TV application, 10% for consumer broadband, 35% for the smart home, and maybe 20% for the enterprise services. So this is another like angle for what your network may look like by having different types of applications, right? So there are multiple choices of technology that an operator can choose from, but a lot of them is really depending on where they see their revenue may come from. And I'm talking about here is the industry's first pass at Convergence. Convergence probably means integrated CCAP today, which consolidate voice, video, and XSD into a single port. And obviously the benefit is the energy, facilities, and maintenance OpEx savings that you probably have seen. And this is probably most of the people would know about that. And there are actually a lot of MSOs that are deploying these type of a CCAP chassis today, mainly for bandwidth reasons, mainly for because they need a lot of downstream traffic. But a lot of them are not integrating video just yet. There are some MSOs that actually integrated video and DOCSIS together, realizing all these benefits from a CCAP. But there are also MSOs that are still just putting more density just for DOCSIS today. So why would they do that? Why would they not integrate video today? I mean, there are actually lots of different reasons, both technical or non-technical reasons, right? For technical reason, it could be they don't want to align the service groups. They have some problems with aligning these RF service groups, video service groups, and DOCSIS service group. And there are also some hurdles that they need to pass within their operations, right? They could have two separate groups one group doing video and another doing DOCSIS, and it may provide challenge when they want to integrate all the tools together with two different groups running different things. So there are actually things that could do that we just haven't done it today. With distributed architecture, with remote PHY, that's actually opened up the door for operators to rethink about doing converged service again, and evolution to virtualization as well. As you probably see at the poll, lots of operators are actually looking at a remote solution, like distributed solution, and that's probably the majority of the vote. Can see that operators are actually thinking heavily on doing distributed architecture. With that, putting video in CCAP makes a lot of sense, right? Because you can eliminate that type of analog optics into the field, and it may give you a better SNR in the end of the day when you integrated CCAP and transmit everything digitally into the remote PHY node. So that kind of forcing the operator to rethink the strategy on how they want to integrate everything into a CCAP chassis and then move it out to the distributed architecture node, and then move it later on with the virtual solution. So I talked about the power saving, energy saving, space saving, and we actually did a case study in one of our customers' head end and trying to understand how much savings that they could actually get, right? We know on paper that everything looks fine, right? Everything converged to one chassis, it was every save space, but actually how much do they save, right? So we went on and actually did a case study with our customer together. And here is the result of that. It's like basically it's covering 3 different service regions with 25 hub sites in total. And the particular operator actually doubled the density on the edge QAMs, on video edge QAMs for VOD, quadrupled the SDV edge QAMs, and also doubled the density of the DOCSIS channels. And as a result of that, they are not doubling the head-end space. On the other hand, there's actually reduced 30% plus for the energy savings and also space saving. So it's a significant saving by reducing 30%, but at the same time, they actually double density of the DOCSIS channels and quadruple the density of the video edge QAMs. And not only that, there are actually some other benefits that's probably being ignored by a lot of operators. Namely, is the number of coax copper cable that they would save. We are talking about 230 kilometers of coax copper cable being saved, 75,000 connectors and 12,000 passives being removed from the network. And that's significant of saving and maintenance on the cable plans. So what are the drivers, right? So from the poll results, right, you see a lot of operators are looking for distributed architecture. And for those who are not ready for that, so what are the drivers for DAA? So the main benefit is, again, is the budget saving. When you do CCAP, you save, if you saw, about 30% of energy and space. But with DAA, you actually save a third of it. So by removing all your analog transmitters and receivers, and removing all the splitters and also the combiners. And those are actually taking a lot of space in the head end that we find out. So if you can remove those, that actually save you further. But obviously, the biggest driver for that is the downstream bandwidth requirements. We have seen operators that they have constantly growth rate on the downstream demand by their subscribers. So we're talking about like 30% to about 50% every year on the downstream bandwidth demand. So how do they go with that without increasing the head-end space, right? So DAA is a perfect example to split the existing node so that they can serve a smaller service group size. And also it's coming from the pressure from the competition, right? That we are talking about a cable MSO maybe getting a lot of pressures from like these fiber providers that give them a gig service. So that is also another driver for them to increase the downstream bandwidth. And DAA obviously can give them the path to go to this increased bandwidth and also reducing budget. And later on, I mean, Cable Labs working on this new standard Photoplex DOCSIS 3.1. So that gives the cable operators another tool that they could compete with a symmetrical service offering like a PON solution. So all these options are available, and there are actually different ways of MSOs are trying to migrate from the existing CMTS servers to ICCAP, to DAA, to virtual solution. So the migration options are, you could do ICCAP first, right, for your near-term head-end savings, as I mentioned earlier. And then you can do a phased approach to the DAA. You don't need to take away your ICCAP all of a sudden to move it to DAA, right? You can pick and choose where you need the bandwidth the most. For example, your MDUs, right? Your MDUs are all wired with coaxial today, and you would like to deploy, because of the bandwidth drivers, you would want to deploy DAA to these MDU first, or you can also do it in areas that you need to do a node split, and that makes the most sense to do DAA. And obviously, you can still work with your existing ICCAP deployments. So there is nothing to prevent you to do one or the other. You can do both together at the same time. And at the end day, the end goal here is to eliminate hub sites so that you can do further savings. So basically, you consolidate different hub sites, maybe multiple hub sites to a couple of them, to help you maintain, to have your maintenance cost for that. So I talk about DAA. So another area that I also want to talk about is PON. When I talk about the migration options in the previous slide, I talk about MDUs, I talk about node split, but how about greenfield, right, where you do not have anything there, you don't have any coaxial cable wired there. So in this case, PON makes a lot of sense. I mean, it could be, we're talking about investment efficiency of PON. If you don't have anything, you just build fiber all the way to the home. So that's another option that operators can get. I mean, we're talking about IP traffic growth rate. A global IP traffic growth rate is about 1 exabyte from 2016 to 2.3 exabytes to 2020. So it's a 2.3 times of a growth rate in 4 years. So that's a lot of growth of data. And again, it's an increasing competition. Even cable operator can actually do PON today, not just for the greenfield, but also the enterprise services. As you saw probably on the previous slide on the chart, there is one of them is the enterprise service that you may want to provide symmetric services. So that will be another way to go to deploy your PON solution. Backhaul for 5G networks, right? Ed from Intel talked about all these wireless technology, and with wireless backhauling, that's another driver for operators for revenue option. So moving forward ahead, right? Slides here. When we talk about wireless and cable all together, you can basically talk about converge these services together. So until this point, I talk about all these different types of access network. And there is also the core side that you could converge, and namely this is the virtual solutions that I highlight here. So you could have a multi-service core with virtual CCAP, your LTE virtual ePDG, and peak gateway together. I'm just naming a few examples here, right? You could have different service functions running in this type of a network virtual solution. And those can be converged together into like a few platform, x86 type of platform together, and provide you multiple different types of service. And this service can give you like a service, like a value added into your revenue. So we're talking about virtual CCAP as a backhaul using voice, your LTE voice over the same network here. So in this, I want to hand it over back to John from IHS on this poll question.
Thanks, Jeff. That's very, very interesting. Yeah, we did want to poll the audience a second time here. And here's our question. Beyond cost and space savings, what are the key benefits you expect from virtualizing cable access networks? And once again, please choose all that apply. Reading through the possible answers, faster time to market for new fixed broadband and or video services, ability to offer fixed and mobile converged services, more efficient ways to tailor services, for example, to enterprises, increased ability to compete with OTT providers, or other. Now let's take a look at our results here. The vast majority, a faster time to market for new fixed broadband and or video services. I don't suppose that comes as too much of a surprise to many of us on the panel. Increased ability to compete with OTT providers is there in second. So again, I don't think that comes as any surprise. Yeah, so thank you for your answers. Now we'll move on to deployment applications, but before I hand it back off to Jeff, I would like to remind the audience, we've got questions coming in, but I'd like to go ahead and remind the audience, please keep sending those questions and we will address them here at the end. And now I'd like to go ahead and hand it back to Jeff to talk about some deployment applications.
All right, thank you, John. Let me just advance to the next slide here. So talk about all these different types of technology, different form factor, and oops, let's go back to one slide here. So how does the cable access architecture evolution looks like, right? So today, on your left-hand side of your screen, you can see this is exactly what cable operators are doing things today, right? With a head end, and then you maybe spin off to multiple hub sites, servicing different MDUs, multiple SFUs in your network, right? HFC. So this is what we look at today. In the near future, right, when you have a DAA solution, then you could basically consolidate some of the hub site together by distributing the physical layer out into the field. So that you can see like remote PHY node here, like surfacing the MDUs or the SFUs, and then going to the hub site, and then going to the head end. And in a little bit further future, then we're talking about virtual solution. And with the centralized data center, that you could put all your virtual service solution over there. That could provide you different types of service functions. And then you could have individual nodes out in the field. Or you could have also an edge data center that you want some sort of a more like latency sensitive type of applications that you want to run. That your node may want to get closer to your data center. You could do that as well. So there could be this type. You can see this type of access architecture is basically trying to reduce the number of hub sites, right? At the end of the day, we want to save money while providing lots of downstream traffic bandwidth. So as a vendor, we actually provide a toolkit that could help the operators to decide what is the best option for them, or what are the best options for them. So, I mean, you are talking about maybe just doing CCAP, like moving a traditional HFC plant. It could be a centralized PON solution that you can go to the greenfield or your enterprise services. You're talking about a distributed access remote PHY node that you want to, for example, you want to split your node, or you want to service your MDUs with coaxial wired. And you can have a remote PON as well at the same time, where you may want to provide some PON solution, or you may want to provide both the DOCSIS and PON solution in the same neighborhood, right? One key example is you could have both coaxial or PON solution available to a neighborhood, and then let your subscribers to cherry pick what you need, kind of like DSL and cable that you've seen today. You probably see like DSL, maybe you can see fiber, you may see cable, but in the future you may see PON, you may see HFC as well. So there are actually different options here that we can provide. And with that, I'm handing back to Ed from Intel to talk about more on the wireless technology.
All right, great. Thanks, Jeff. So obviously lots of considerations for operators as they try to figure out how to evolve their access network. So here's yet another one, right? So wireless. Wireless, of course, is top of mind these days. Lots of buzz out in the industry regarding 5G, and whether you're an operator who is actually considering getting into the wireless business, as we've seen in the news of late, or if you're simply interested in backhauling for others, a model which we think will become more and more important as the 5G network gets densified with small cells as an example. So we think that wireless is a key consideration for you as you decide how to evolve your access network. And so I wanted to take a look at what's going on in the wireless space today. And it turns out that wireless providers are also debating split access architectures. And I'll go through each of these starting at the top. So in today's world, I guess you would label this as sort of remote MAC-PHY on steroids. Basically, the wireless folks have a very, very distributed network. The access portion, there are a lot of elements to the access portion which literally live at the bottom of a lot of cell towers and cell sites. And then there's Ethernet or IP backhaul to the core wireless network. And this type of an architecture has its advantages and it has its downsides as well. One of the key advantages is that the demands on the network are not all that great from a latency and throughput perspective. So lots and lots of backhaul networks can meet the requirements for today's backhaul. But one of the key downsides is, first of all, higher cost. There are an awful lot of these cell sites, so the more smarts you put in the bottom of those towers, the higher the cost, the higher the power. Some of these sites are very remote, therefore they can be challenging to maintain as well. But even more importantly, these towers or these RAN elements have relatively low average utilization, and the reason for that is because the usage changes over the course of a day. For example, during the day, urban areas are going to have high utilization. People are at work. In the evening, those same areas are going to have very, very low utilization. Instead, all that traffic moves to the suburban sites. What the wireless operators really want to do is to consolidate some of the processing such that they can sort of load balance, if you will, and drive up the overall utilization of their equipment. So going down the list, I'll talk about split RAN next. Split RAN actually emerged after CRAN, which I'll talk about in a second, but split RAN is analogous to R5. It's essentially moving out the layer 1 processing and consolidating the layer 2 and layer 3 type processing. Maps directly to kind of an R5 network. And this particular model seems to have the most legs in the industry, if you will, and I think the reason is because it offers a balance between the desire to consolidate and drive up utilization, but also it has sort of medium demands on the actual backhaul network in terms of throughput and latency, and therefore there's adequate infrastructure in place to backhaul these many cell sites, right? Moving down the list, CRAN, or Consolidated Radio Access Network, is actually where the industry started. And what's kind of interesting here is that this kind of looks like today's MSO network, where basically you've got just the RF out there and you're backhauling everything and doing all the processing centralized. So it turns out in the wireless world, the wireless folks just don't have the network infrastructure to support that kind of a model, at least not universally. There are some areas that have very good low latency type fiber, but not ubiquitous by any means. So even though this might be the most desirable model from a consolidation perspective, the networks just can't support it. And of course, you might say, well, okay, that's where the operators are today. Why not stick with that model, that sort of consolidated model? Of course, the challenge we talked about earlier is the power and space constraints in these subsites and head ends. So the net of all of this is that the wireless guys seem to be coming at this from a different direction than the MSOs, but both seem to be converging on a similar model, namely the split RAN model or the R5 model in the middle. So what would this mean from a HFC type network, how might you sort of deploy a split RAN model? Well, I think the key here is that the split RAN model maps very well to today's HFC network. And in this example, I'm showing that you could essentially do the layer 1, the RF front end type stuff, either in the neighborhood, in a fiber node, or alternatively or in the home, right? And then do the rest of the stack back in the hub site, again, completely mapping into the R5 sort of model. So we believe these architectures are very complementary, and it's fundamentally pretty straightforward from a architecture perspective to map these two networks together. And especially if you've got fiber nodes that are based upon FPGAs, which can, of course, be programmed and reprogrammed to support additional networks over time as that evolves. Okay, so now I'm going to keep the mic, but I'm going to shift gears a little bit and just talk to you about Intel products and how they sort of map into this space, and also how we go to market. So for those of you who've been in the MSO space for a while, you may know Intel from our cable modem products. Specifically, we've got our Puma system on a chip, which is found in many gateways throughout the world. But you might not realize that we're in several different areas now through growth and acquisition as well. So as an example, we acquired Altera, who manufactures FPGAs, which are finding their way into these fiber nodes. And again, by using FPGAs in those nodes, you can sort of adapt and add multiple networks and services over time as needed. And of course, you know and love us for data center products as well, but you may not realize that we actually have significant footprint in wireless, everything from macro cells to small cells in today's 4G world, and certainly we're investing very, very heavily in 5G as well. So I guess my ask out of this slide is when you think wireless, think Intel. So in terms of how we go to market, we're a silicon manufacturer, but we do much more. We do lots and lots of what we call enabling to make sure that our technology finds its way into end customer solutions. And we do that through a number of different methods. First and foremost, we do a lot of work in open source and standards. And of course, that's a great way for us to ensure that our silicon technology gets exposed up through the software stack such that applications can take advantage of them. We also deliver what we call open reference architectures. So these are essentially recipes. Think of these as software and hardware stacks that are sort of tuned to fit a use case or a set of specific use cases. And then, of course, we have a very large and thriving ecosystem that we've built through a program we call Intel Network Builders. And finally, we really like to collaborate together with our ecosystem and end customers, consumers of our technology. And that's so that, especially on the big sort of industry transitions, and that's so that we can be sure that we're building the technology that's going to ultimately meet the requirements of the folks who deploy that technology, like the MSOs, as an example. So over to you, Jeff.
All right. Thanks, Ed. So I'm going to do a little plug here. So we talk about all these converged, upgrades, distributed solution. Is the slide showing up yet?
Yeah.
Okay. So, I mean, Casa Systems provides these type of solutions. As I mentioned, that we provide like a toolkit for any type of future technology that you would need. So we have our existing CCAP chassis today, like a C100G, that could do your conversion, and meaning that you could have voice, video, and data together into our existing chassis, and then you can obviously upgrade it to do DOCSIS 3.1 with that, and then you can migrate to our remote PHY node with a distributed solution, and then densify your network. We also provide PON solution in our portfolio, and obviously we have our Axiom platform that we could support the virtual CCAP and all these other like wireless Wi-Fi technology that we can run on this Axiom platform. So it's basically the whole thing about converge and then densify and virtualize to see the savings for the operators. And then, right, so to sum it up, so the future would be converged. For distributors' future, so we have something like an edge data center where you could have your maybe IoT sensitive applications running there with your DAA solution out in the field, or you could have a central office type of applications with your virtual servers in there, and then you go out to distributed access nodes. So, there are actually many different ways of how you will see this type of service. But again, it's not just purely for cable. It's also for some other services like wireless, like on any IP services that you want to play with it, firewall, load balancer, DPI. You could all run into the same type of multi-service core in your server. So that allows you to provide different types of service functions for operator. So with that, I hand it back to you, John, for wrap up.
Great, thanks, Ed. Thanks, Jeff. Now I'd just like to go through some conclusions rather quickly because we have a lot of questions to get to. So once again, the case for CCAP, the future network does depend on the strategic revenue plan for operators. So as outlined early in the presentation, that can take the form of broadband, it can take the form of pay TV, it can take the form of enterprise services. But one thing is clear, that fiber will be an important element of the network. Initially, that's taking the form of 10 gig EPON at present. And what was once distributed, then converged, will distribute again in a more innovative way, depending on the strategic focus of service providers. And again, that most important element is taking that strategic approach to identify the network architecture that is best fit. So with that, I'd like to go ahead and move us to Q&A. So I'd like to start with a question. Is coaxial cable being phased out in the connection of the new architectures?
I honestly don't think so, because actually, as you probably knew, that Cable Labs is still working on the next generation of DOCSIS 3.1, which is called the Photoplex DOCSIS 3.1, and there are still a lot of legs in the coaxial cable today. You're not phasing the coaxial cable out. And when we talk about this Photoplex DOCSIS, we're talking about like 10 gig service, and so it's definitely not phasing out, right? It's just a different type of choices here rather than one phasing out the other. It's kind of like they live together. For example, if you're a greenfield, you don't have anything. Operators tend to do a fiber optics deployment, but for the existing HFC, you're not going to replace it. There's still a lot of legs. A lot of bandwidth that you could provide on the HFC.
Yeah, John, I would agree with that, and I'd actually go a step further and say that in brownfield anyway, that coax and the existence of coax into the home is a strategic asset for the MSOs because, we all know that laying fiber to the home in brownfield is quite expensive, right? So coax is a cost-effective alternative to gig speed.
Okay, thank you, and that all makes sense. Our next question is, how does DOCSIS 3.1 impact the choice to go towards distributed architecture?
I don't think it actually impacts at all. I think they are kind of different, right? If you are looking at increasing bandwidth, obviously you could do both DOCSIS 3.1 and DAA, but a lot of them is also depending on whether you have the frequency spectrum on that, right? When you have DOCSIS 3.1, you're talking about 192 megahertz of FDM block. You can use a small block. But whether your plant has enough spectrum, you don't know. And with DAA, I mean, it's kind of like attacking a different type of problem, right? It's basically using the same spectrum, but then you have fewer users on it. So they are kind of independent of each other. So, I mean, you could do both. You could do one of them. It just really doesn't impact each other at all.
Okay, that makes sense. Another question here. Can you all provide more on the pros and cons of Phi versus MAC-Phi? I assume that's referring to remote. What are the major MSOs favoring at this point from your perspective?
So obviously there are, like, we talk about a lot of pros and different cons on each technology, but from what I've seen in the industry, I mean, most of the, a lot of the MSOs are more favored to a remote PHY technology. I mean, the main reason for that is it's a simpler device out in the field, and they hate doing truck rolls when they maintain the DAA node out in the field. That's obviously one big reason. I mean, that every time when there's a truck roll, it's a lot of cost problem for them. I mean, if you run a MAC layer in the field, obviously it's you're basically running a lot of software out in the field, and it's not just the number of line of code that you are running; it's also the frequency, the runtime of it. We've done a study here that 95% actually of our code is actually on the MAC layer, and 5% is only physical layer. So, and in addition to that, there are lots of messaging between MAC and your core. So there's actually a lot of runtime that would affect your node. So if you want to keep these complex cases out, that will simplify the operation of the operators. And the other advantage for that is you're talking about power. So a lot of the field, I mean, you put it in the pole, you put it in the cabinet. There are actually lots of power requirements that you need to put into your node. And when you have MAC there, obviously your power consumption, your heat dissipation will go up. So that's another thing that operators are considering.
Yeah, and I agree with all that, Jeff, and I'll add that full duplex is going to also put additional power requirements on those nodes, and so adding MAC-Phi and then FDX might be too much in terms of power. So agree with that assessment, and we do see most of the focus in the industry these days on remote PHY.
Okay, great. Our next question is Casa PON capable of DOCSIS provisioning over EPON?
Yeah, absolutely. So that's actually a very important feature, especially for the cable operator who have been using a DOCSIS provisioning system today, and they would like to do it for their greenfield applications or for their business customers. So that's a key feature that we have, and it's saving them for having a separate system to provision or to manage their PON network. So basically, their DOCSIS service and the PON network can coexist in the same chassis using the same provisioning server. So that's a big benefit for OpEx-wise and CapEx for the operator.
Okay, and our next question is Casa RFi and Axiom available today? If not, when would that be available?
Yes, it's absolutely, Casa RFi is definitely available today. Axiom is available today as well. So both yes and yes.
Okay, and then I had a question for me asking about the total of growth of the CCAP shipments on my chart. The question was, what constitutes the shipment? Those shipments are constituted of DOCSIS channels that are going out. Our next question would be, will virtual CCAP be able to deliver the same services as physical CCAPs, and when would that be?
Oh yeah, absolutely. That's absolutely the goal for virtual CCAP to deliver the same service. And I also talk about the multi-service as well. So you're basically talking even more service than existing physical CCAP. We're talking about like service function chaining that you could provide more than what we just CCAP. You're talking about WAC, you're talking about Wi-Fi, you're talking about wireless service. You could be adding firewall. You can be adding anything in there in the same server, like for example, our XM platform. So yes, that certainly is the goal, and I think it's going to be available very, very, very soon. I probably see something. Some operators will be like doing trials like next year. So this is not like a distant future. This is happening now, and obviously in our previous shows, like in Europe, in ANGA, when we have shown out to our operators that using our XM platform, we could actually deliver this type of a voice over Wi-Fi servers using cable as a backhaul. So we're talking about converged multi-service on the virtual CCAP platform.
Yeah, and John, just to add to that, from an Intel perspective, going back several years, when we first started in this sort of network functions virtualization journey, that's something we're very heavily invested in. We had a lot of questions about the ability of standard servers to perform to the levels of purpose-built equipment, and we continue to make huge strides on that front, and to the point where with the CCAP element in particular, I do believe we can deliver performance in the right thermal and sort of footprint requirements as well to meet to replace that sort of traditional CCAP element. And so we do get a lot of questions about that. So if you haven't looked at our technology in a while, we invite you to have a conversation about the improvements we made in terms of packet processing.
Okay, good. We have time for maybe one more question. We do have a lot more questions in the queue, which we will have to take offline, but we will, our panel will follow up after the webinar with some of these questions that we're not going to be able to get to as we're a little short on time. I'd like to go ahead and ask, how much cost and space savings can service providers expect from distributed access?
This is actually a very good question, and actually a very difficult question to answer. The reason being that every operator is different. So depending on what they have today in their network, whether they have already done ICCAP, also factor into it. But to just give you an example, right? We actually did a site study recently with one of our customers. And we are talking about reducing 63 racks down to 2 racks. And we're talking about deploying, it was from a CMTS deployment into a DA deployment, right? A lot of racks were reduced, not just because removing the CMTS, we're using CCAP to do the aggregations of the remote PHY nodes, but we are also talking about removing 71 optical shelves from that network. Those are the analog devices that we actually remove. So that's basically removing both the optical transmitter receiver and also the RF combining. The RF combining doesn't take a lot of power, but it does take a lot of space. So that's actually a big time reduction on the space by doing a DA solution.
Thanks for that. And with that, I'd like to hand it back off to Alan for our final wrap. I'd like to thank everybody, especially our panel, Ed, Jeff, for being on the panel, but also I'd like to thank the audience members for some great questions today. Alan, I'm going to hand it off to you.
Thanks, John, and also a special thank you to you for leading our discussion as well. So an archived version of this webinar will be made available shortly, so feel free to come back again and view this session or even share it with your colleagues. Now you're going to see a short survey pop up at the conclusion of our webinar. We'd love to get your feedback, so please take a few minutes to fill that out. And make sure you follow us on Twitter for information on future IHS Markit Technology Group webinars. So again, thank you for joining us, and have a great rest of your day.